Part 3 of our tutorial series, I'm going to be talking about guarded suspension. With the guarded suspension design pattern, we block the actions of an object that require both a lock to be acquired and a precondition to be satisfied. The object is blocked by suspending the method and the invoking thread until the precondition is satisfied. Java provides a handy way to implement this using both their wait and notify methods from the object class, which we'll take a look at that in our software examples. Okay, let's take a look at these diagrams here. So the diagram at the top, we've got a flow chart here showing the control of the object here. So we've got the synchronize method being invoked. We check to see if the precondition has been met. If not, we block the thread until we become unblocked using the notify method. Once the precondition has been met and we're unblocked, we proceed and go ahead and perform the action. Okay, looking down here at this UML diagram, we've got our guarded suspension object here, which has our ready variable. This is going to be our control variable. We have our guarded method and our make ready method to change the control variable. We also have our test class here. Okay, let's go over to Eclipse and take a look at the code. Okay, so here's our control variable, our ready. We've got our guarded method here that checks to see if ready is true. That's our precondition. If not, it waits, which is blocking, until the precondition changes and it's notified. Once that does happen, we perform the action, which in this case we just print out action performed. Then here in our make ready method, we set ready to true and call the notify all method to notify blocked threads. It's important to note that both the guarded method and the make ready method are both synchronized. Okay, let's take a look at our test class here. So we've got our guarded suspension object being created. Our test thread 1, we are invoking our guarded method on our object, and immediately when that thread starts. Our test thread 2, start up the thread, we have a delay here, and then we call the make ready. So what should happen here is both threads should start up. We should try to call the guarded method, but it won't complete until the second thread calls the make ready method. So we should be able to see that printout here. Okay, I'll go ahead and run it and take a look here. Okay, requesting action, making ready, and then action performed. Everything looks good there. Okay, time for an example application. Let's keep adding to our car example, and now let's add air conditioning to our car. So it's air conditioning. We need an air conditioning object. We should wait until the car is running before we start the AC. We should be able to accept user adjustments as soon as the driver starts using the car. We also need to ensure that there's only one instance of this class in existence in our system. So again, this is a good fit for the singleton pattern as well. Okay, here we have a UML diagram of our example program here. We've added the air conditioning object now, so we've got a temperature variable, our AC running. This is our control variable that we're going to be monitoring. Get instance for a singleton pattern, start AC, and set temp. Not many changes to the car or cruise control here in the diagram level, but there are some small changes to the car object, and we'll go ahead and take a look at that right now in the code. Okay. So first, let's look at our new air conditioning object. We've got our singleton pattern implemented here. We've got our private static object instance. We've got our private constructor and our public get instance. We've implemented double checked locking to check and create a new instance as needed. All right, here is our start AC method here, where this is, once this is called, we set AC running to true. That's our control variable there, and notify all blocked threads. We also see our set temp method here. So this is our blocking method here. We've got check our precondition. If it's false, we wait. And when we become unblocked, then we go ahead and set the AC temperature to this input temp and print out a message that that's happened. Okay, we've got both the start AC and the set temp methods here are synchronized. Again, very important. All right, let's take a look at the car class here. So, slight change in the start method, we've added starting the AC. That's it. That's the only change here. And now let's look at our road trip test class. So very similar to our test class from part 2. We've got our foot controls, operating the car. We took out the second brake statement. We don't want to slow down too much on our road trip. Our second thread here, our cruise control thread, is pretty much the same as before. Now we've added a AC control test thread as well. So when this starts up, try to just set the air conditioning to 75 immediately. So let's go ahead and run this, and we'll see what kind of results we get. Alright, looks like we had some events firing off here. Thread 3 happened first, which is, this is thread 3 right here. This was setting the temp. So that happened, but we didn't set the temp until after the car started. We got ignition success, started the AC, and then the temperature setting was actually applied to the AC. Then soon after that, I did some accelerating, started cruise control, picked up, and now we're on our way. Alright, let's talk about some implications of this pattern. So pros, this is a lot more efficient than spin locking, which is, it's basically like sitting in a while loop constantly checking the precondition rather than having this sort of thread blocking mechanism in there to conserve resources. Cons are, if the method is suspended for too long, the application could slow down or stop. So you really have to be cautious when you're planning to use this pattern to make sure that it's not going to be blocked for too long. Alright, and that concludes our tutorial series. I hope you enjoyed it, and stay tuned for more.